Alright, in this little video I'm going to talk about the intensity of a wave and the energy transported by a wave. Up at the top there's a basic definition of the intensity of a wave. It's the power transported across an area perpendicular to the direction of the energy flow. You can kind of think of this as, as a wave is moving in one direction. When it reaches a target, it's perpendicular to it. So it's how much energy is distributed amongst that particular target, which is perpendicular to the flow of that energy. Therefore, we can give ourselves a little equation here that says the intensity is the energy per unit time, or better known as power, divided by the area. Now, if you do that, if you get that particular formula, you're looking at watts per meter squared. Okay. If we talk about the energy, and we had talked about this the other day when we talked about simple harmonic motion, but when an object is at its maximum amplitude, there's no kinetic energy at that point, and all the energy is contained in, say, elastic potential, which would be equal to 1/2 kx squared, but where x is equal to the amplitude. So we could say that the energy transported by the waves is also equivalent to 1/2 k a squared. Okay, the energy transported by a wave is proportional to the square of our amplitude. So, since the energy is proportional to the amplitude squared, okay, and intensity is also proportional to energy, then I can also say that the intensity is proportional to the amplitude squared. Okay. So a couple of little applications of these two little ideas is the idea that when you have a sound wave, when it comes out of a source, it is spherical in nature. Therefore, the intensity of the wave, being the power per unit area, would be equal to the power and then the area of a sphere. Okay, so you're going to have to make sure that you know that particular formula. Now, in this particular equation, you'll notice that the intensity of the wave is inversely proportional to the square root, or to the square of the radius. Okay, so as long as the power, okay, so like if you set your stereo to a certain volume, okay, then the intensity of that is inversely proportional to how far away from the speakers you are. Okay, so a very useful little ratio for you if you want to compare the intensities of the wave at different radii is if you set up, because this intensity and the radius are opposite of each other, I could set up a ratio where I'd say intensity 2 over intensity 1 is equal to the radius squared from 1 divided by the radius squared from 2. Okay, because these are still inverses of each other. This is a helpful ratio if you want to compare the intensity to the radius. One other connection that we can make is we can compare the intensity to the amplitude. Okay, back up here I just said that the intensity is proportional to the amplitude squared. Well, then if intensity is proportional to 1 over the radius squared, well then amplitude squared should be proportional to 1 over the radius squared. So the squares will go away, and we know that the amplitude, okay, squared is inversely proportional to the radius. So you can come up with this ratio as well. So those are just a couple helpful ratios that might be worthwhile knowing for doing some problems. Okay.